Hi guys, welcome back to my channel and today's topic is pipe roughness estimation in field. This is one of the parameter which is required for calibration of water supply distribution network. Roughness values are given in manuals, standards, codes and also by the pipe manufacturers for different kind of pipe. Pipe roughness depends on pipe material, diameter of the pipe and with the age of the pipe due to tuberculations and chemistry of the pipe. Now we think on which pipe we should do field estimation of roughness, the old pipe or on the new pipe. The answer is for the both kind of pipe. If we draw a graph between age of pipe and roughness, then we see that roughness increases with age of pipe and the head required to pump a flow is increases and the motor associated with the pumps needed more electricity and more opex is required to pay large electricity bills. When we design a water supply distribution network on a computerized software, then we take a theoretical value of roughness coefficient, but there are several composite secondary factors, for example, the fittings and the skeleton of the pipe, which impact the value of roughness coefficient, which is generally not considered while designing the system. Now I am going to show you the procedure and steps for field estimation of roughness coefficient. We have selected a pipe section here where there is a pressure hydrant 1, the pressure hydrant 2 and a flow hydrant, and the downstream of the flow hydrant there is a wall and the direction of the flow should be from pressure hydrant 1 to 2. Now we have to install a pressure gauge 1 at the pressure hydrant 1, the pressure gauge 2 at the pressure hydrant 2 and the flow meter at the flow hydrant, and measure the length between pressure hydrant 1 to 2 and measure the diameter of the pipe. Now step 1 is measure the pressure drop. This is the pipe section installed with two pressure gauges. Give the reading Pg1 and the Pg2. Now the pressure drop is Pg1 minus Pg2. If pressure drop is less in line due to large diameter of pipes, then increase the size of nozzle. This generally happen because large diameter of pipe have larger volume of water and to discharge that water we require big size of nozzle. Otherwise, the pressure difference between the Pg1 and Pg2 will not be substantial and the test will not be effective in the field, and the pressure drop is proportional to the flow from the nozzle. Now the step 2 is calculate the flow. This is the formula to calculate the flow from the nozzle. CD equal to nozzle discharge coefficient, dn equal to nozzle diameter and PD is equal to pressure drop. Now the value is CD also depend upon the type of the nozzle. These are the values given for the different type of nozzles. Now step 3 is calculate the inline velocity, and this is the formula to calculate the velocity, and now put the value of QP from the step 2 in this formula to get the value of inline velocity. Step 4 is calculate hydraulic gradient. This is the formula for the hydraulic gradient where HP is equal to head loss between pressure gauge 1 and pressure gauge 2. HP is equal to PD plus Z1 minus Z2. Z1 and Z2 are elevation at the pressure gauge 1 and pressure gauge 2, and PD is equal to pressure drop which we have already calculated under step 1. LP is equal to length between the pressure gauge 1 and pressure gauge 2. This is the pipe section with two pressure gauges at elevation Z1 and Z2, and the length between these two pressure gauges are LP. Now step 5 is calculate the Hazen-Williams coefficient. This is the formula to calculate the value of Hazen-Williams coefficient. Now, whatever value we get from this formula, we have to put that value in the water supply distribution model where we have used the theoretical value. Now, after putting these values, we have to know what are the pressure at the different nodes and calibrate the water supply network model accordingly. Here are some general observations and suggestions for field estimation of roughness coefficient. The method outlined in this video work well with small lines generally diameter less than 400 mm. The test efficiency decreases as you deal with large diameter of lines. For large diameter pipes, normally opening hydrants does not discharge enough flow for measurable head loss. Therefore, for the head loss test for large diameter of lines must conducted for sufficient large length and use flow meter at pump stations or change in tank level to measure the flow. Make a visual survey of the test area before conducting a pipe roughness test. Adequate drainage should be available away from the flow hydrant. Ensure hydrant nozzle do not discharge into nearby road traffic. Provide safety measures during the test, put up traffic signs and use traffic cones. Use pressure snubbers to eliminate the transient effect in the pressure gauges. A pressure snubber is a small valve that is placed between the pressure gauge and the hydrant cap, which acts as a surge inhibitor. I will come again with new topics.